Hello and welcome dear student in the next lecture. So dear student, just in the last lecture we have completed a first topic, that is solid state, from our chemistry. So welcome all of you dear student in the next, that is the second topic from our chemistry, a very interesting topic, solutions. So welcome all of you in the second topic, solution. What is mean by solution? So in the introduction of this topic we have to see the definition of the solution and the classification of the solution. So first of all, see what is mean by solution. A solution is a mixture of, in the definition of a solution, what we can say, a solution is, here a solution is a mixture of two or more components. A solution is a mixture of two or more components. So what is mean by solution? A solution, it is a mixture of two or more components. So depending on the size of the components, as we see in our 11th standard topic, adsorption and collides. Depending on the size of the components, the mixtures, depending on the size of the component, the mixtures are classified into three main types. So dear student, depending on the size of the components, the mixtures are classified into three main types. The first type of mixture is a coarse mixture. The first type of a mixture is a coarse mixture. In which the size of the component is relatively bigger. The size of the component is, for the coarse mixture, the size of the component is relatively bigger and it forms a heterogeneous mixture. For example, the mixture of salt and sugar is a coarse mixture in which the size of the component is relatively bigger. That means they can be seen by our naked eyes, and it forms a heterogeneous mixture. The second type of mixture is colloidal dispersion. In a colloidal dispersion, a dispersed particle is in the range of 10 raised to -7 to 10 raised to -4 centimeter. In the colloidal dispersion, the particle ranges in between 10 raised to -7 to 10 raised to -4 centimeter. It also forms a heterogeneous mixture. And the example of this colloidal dispersion that we have seen our 11th standard topic, adsorption and collides. That means here in a colloidal dispersion, it forms a heterogeneous mixture. And the example of the sulfur gel or hydroxide gel. The example of this type of a colloidal Colloidal dispersion is the hydroxide gel or the sulfuric gel. And a third and a very important type of mixture is a true solution. A true solution is a homogeneous mixture of the substances. A true solution is a homogeneous mixture of the substances. That means the soluble substances the substances they are soluble in a solvent. That means the substances they are soluble in a solvent. So dear student, in the true solutions, the particle size ranges in between, means the particle size is 10 raised to minus 8 centimeter. So here a solution is a mixture of 2 or more components. So depending on the size of the components, the mixtures are broadly classified into the 3 types. A coarse mixture, in which the particle size of the component is relatively bigger and it is a heterogeneous mixture. For example, the mixture of sugar and salt. The second type of a mixture is colloidal dispersion, in which the particle size ranges in between 10 raised to minus 7 to 10 raised to minus 4 centimeter. It also forms a heterogeneous mixture. That means, for example, hydroxide salt or the sulfuric salt. And a true solution, in which the particle is soluble in a solvent. The particles they are soluble in a solvent and it forms a homogeneous mixture. And the particle size is near about 10 raised to minus 8 centimeter. So dear student, these are the classification of the mixture depending on the size of the component. So dear student, in this topic solution, we are going to study only the solution, that means a true solution, in details. So, what is mean by solution? By the definition, a solution is a homogeneous mixture of that means a true solution is a homogeneous mixture of homogeneous mixture of 2 or more substances. So the solution is a homogeneous mixture of 2 or more substances, and therefore the substances involved in a solution, when it forms a solution, or the substances involved in a mixture, when it forms a homogeneous mixture, then the substances involved they are solute and solvent. Means a homogeneous mixture of 2 or more substances, means a solution is a homogeneous mixture. What is mean by the homogeneous? Homogeneous means all the components present in that solutions, they are present only in one phase, only in one state. The opposite of the homogeneous is heterogeneous mixture, and in a heterogeneous mixture, the involved substances they are present in a different phase. But a solution is a homogeneous mixture, means in a solutions the involved components they are present in the same phase or in the same state. So the solution is a homogeneous mixture of 2 or more substances, and therefore the word substances means it contains a solvent and solute. So the solution is formed from solvent and solvent and solute? Solvent constitute a major part of the solution, or the major component of the solution is called as a solvent, and a minor component of the solution is called as a solute. So from the solute and solvent, a solution is formed. A solution is formed from the solvent and a solute. In that, a solvent constitutes a major component of the solution, and a solute is the minor component of the solution. For example, if we consider a solution of a salt in a water, if we add a salt in a water, then it forms which type of a solution? It forms a homogeneous solution. And therefore, in this solution, these two components are present. One which is called as a solvent, and the another one is called as a solute. So, in this salt solution, the H2O, which constitute a major part of that solution, and therefore the H2O is called as a solvent, and a salt which is added to that solvent, and therefore it constitutes a minor part of that solution, or it is a minor component of the solution, and therefore salt is called as a solute. So from the solute and solvent solution, it will be formed. Therefore, when the solution is formed from the solute and solvent, the interaction of the solvent and the solute to form aggregation called as a solvation. That means when a solution is formed from the solute and the solvent, there must be an interaction between the solute and solvent to form an aggregate. Then it is called as a solvation. Solvation means the interaction between the solute and solvent to form a solution. And always remember that student, if the solvent used in the solution is a water, then that solvation process is called as a hydration or aquation. The interaction between the solute and solvent to form aggregates is called as a solvation. म्हणजे जेव्हा सोल्युशन तयार होताना सोल्यूट आणि सॉल्व्हेंट ची इंटरॅक्शन होते, because the solute and solvent forms a solution, and when they comes closer, then they interact with each other to form a solution, and that process of the interaction between the solute and solvent to form a solution is called as a solvation. But if only the water is used as a solvent to form a solution, then that process is called as a solvation or hydration process. It is called as a solvation or hydration process. So dear student, solution is a homogeneous mixture of two or more substances, and therefore the substances involved in the solutions are solvent and solute. Solvent constitutes a major component of the solution, and a solute constitutes a minor part of the solution. And the interaction of the solvent and a solute to form aggregation called as a solvation. And if we use the water as a solvent only, then that solvation process is called as a hydration or aquation. The extent to which the solute dissolve depends on the nature of solute and a solvent. The extent to which means here how the solute interact with the solvent to form a solution. That means the extent to which a solute dissolved in a solvent depends on the nature of the solute and solvent. That means what? By the rule, लाईक डिझॉल्व लाईक. म्हणजेच दिलेला सोल्यूट हा सॉल्व्हेंट मध्ये किती प्रमाणात डिझॉल्व होणार आहे सोल्युशन तयार होण्यासाठी. फॉर द फॉर्मेशन ऑफ अ सोल्युशन वी रिक्वायर्ड ॲटलीस्ट 2 components, solute and solvent, and therefore the interaction between the solute and solvent to form an aggregate called as solvation, and the extent to which the solute react with the solvent or the solute interact with the solvent, it depends on. म्हणजे दिलेला सोल्यूट हा सॉल्व्हेंट बरोबर किती रिॲक्ट होणार आहे, किती इंटरॅक्ट होणार आहे, and it depends on the nature of solute and solvent. That means by the rule like dissolve like, as we know. म्हणजेच काय, what is mean by like dissolve like? फॉर एक्झाम्पल, मी तुम्हाला एक्झाम्पल दिलंच होतं 11वी मध्ये, पण आपलं कोणाबरोबर पटतं जास्त, आपल्या कोण मैत्रिणी होऊ शकतात, ज्या आपल्यासारख्या असतील त्या. आपल्यासारख्या स्वभावाच्या मैत्रिणींशीच आपल्याबरोबर मैत्री होते. तसंच सोल्युशन तयार होताना सॉल्व्हंट आणि सोल्यूट यांच्या नेचरवरती डिपेंडेड आहे तयार झालेलं सोल्युशन हे कसं असणार आहे. लाईक डिझॉल्व लाईक, दॅट मीन्स अ पोलर सोल्यूट dissolved in a polar solvent and a non-polar solute dissolved in a non-polar solvent. That means a like dissolved like. A polar solute, that means NaCl dissolved in a water. NaCl is a polar because it forms 2 poles. H2O, it is also a polar molecule. It forms 2 poles, H plus and OH minus ions, and therefore when a polar solute dissolved in a non-polar when a polar solute dissolved in a polar solvent, then it forms a solution according to the rule like dissolve like. And a non-polar solute is preferentially dissolved in a non-polar solvent. That means according to the rule like dissolve like, the solute dissolved in a solvent depending on the nature of these solute and solvent, according to the rule like dissolve like. So this is one of the introductory part of the solution, that means the definition of the solution and the classification of the mixtures into the 3 types from the topic adsorption and a collide. So next to that we have discussed here the classification of the solution in detail. So let us see the classification of the solution in detail. So the solution are broadly classified into the 2 types. The first one is now depending on the number of components, and the second one is depending on the physical state of the solute and solvent. So here this is the classification of the solution. The first one, the solution depending on the number of components, that means in the solution if the number of components are 2, if in the solution the number of components are 2, then that solution means depending on the number of components, the solutions are classified into 3 types. If the number of components are 2, then that solution is called as a binary solution. Means binary means only the 2 components are involved to form a solution. One solute and another one is a solvent. If the number of components are 3, then the solution formed is called as a tertiary or ternary solution. And if the component involved in the solutions are 4, then that type of a solution is called as a quaternary solution. So depending on the number of components, the solutions are classified into the binary solution, ternary solution and quaternary solution. This is the classification of the solution depending on the number of components. But dear student, always remember that in this topic solutions, we are going to study only a binary solution. Means it contains, in a binary solution, it contains one solute and one solvent. So it contains only one solute and one solvent. So in this topic we are going to study only the binary solution. The next type of a solution, it depends on the physical state of the solute and solvent. What is meant by physical state of the solute and solvent? As we know, there are three states of matter: solid, liquid and gas. And for the binary solution, if we consider the physical state of the solute and a solvent, there are 9 types of a solution is formed depending on the physical state of the solute and solvent. So, depending on the physical state of the solute and solvent, that means either they are present in a solid state or in a liquid state or in a gaseous state. There are 9 different types of solution depending on the physical state of the solute and solvent. And therefore, here we are going to discuss the physical, depending on the physical state of the solute and solvent, there are 9 types of a solution. And how they are classified, that part we have seen here. So, here we have a classification of the solution depending on the physical state of solute and solvent. That means, if the solute present in the solid state and the solvent present in the liquid state, then it forms a solid in a liquid type of a solution. For example, sea water. For example, sea water. Then next, if the state of the solute is solid and the state of the solvent is also solid, and as we know, solid in solid, that type of a solution is called as alloys. And we know about the bronze and stainless steel from our first topic, solid state. So this is the second type of solution, when the state of the solute is solid and the state of the solvent is also solid. Then if the state of the solute is solid but the state of the solvent is gas, then it forms a solid in gas type of a solution. And the example of this type of a solution is iodine in air, because iodine present in the solid state and air it is present in the gaseous state. Then, so these are the types of state of the solute. If it is liquid and the state of the solvent is liquid, then it forms ethanol in H2O. This type of a solution. That means liquid in liquid type of a solution. Then next, if the state of the solute is liquid and the state of the solvent is solid, then it forms liquid in solid type of a solution. For example, amalgams of mercuries. Then next, if the state of the solute is liquid and the state of the solvent is gas, then it forms liquid in gas. Here, the solvent which constitutes the major part of the solution and the solute which constitutes the minor part of the solution, and in liquid in gas type of a solution. For example, here chloroform in N2, nitrogen. This is the example of a liquid in gas type of a solution. Then in gas and liquid type of a solution, here gas is the solute and the liquid is the solvent. Then for example, gas and liquid type of a solution, a carbonated air or our cold drinks, it is an example of the gas and liquid type of a solution. Then next, if gas is a solute and solid are the solvents, then it forms H2 in palladium. H2 which is present in the gaseous state, therefore it acts as a solute, and the palladium or platinums, they act as a solid. So it forms a gas in solid type of a solution. For example, H2 in presence of palladium, which acts as a catalyst, as we know, in many reactions. And the last type of a solution is gas in gas. But the gas in gas type of a solution, when two or more gases mix together, then they form a homogeneous mixture, and this property is called as a diffusion. And this is one of the property of the gas states or the gaseous molecules. For example, the gas in gas type of a solution, for example, the mixture of air. Air is a mixture of many more gases. So, dear student, depending on the number of components, there are three types of a solution: binary solution, ternary or tertiary solution, and quaternary solution. And depending on the physical state of the solute and solvent, there are 9 types of solutions they are formed: solid in solid, solid in liquid, solid in gas, liquid in liquid, liquid in solid, liquid in gas, gas in liquid, gas in solid, and gas in gas. So these are the 9 types of a solution. They are formed depending on the physical state of the solute and solvent. So dear student, in this today's first topic from the first lecture from the topic solution, we have stopped here. We will meet in this topic with the next module. This is a very interesting topic. So dear student, we will stop here in today's lecture. We will meet in the next module. Till then, thank you.